something instruction, we will see. I'll find out what is the termination instruction. Actually, there should be a termination instruction before end. Before end, there should be a termination of the program instruction. I'll find out and check you that. I'll give you that. Okay. So hope you understood what exactly this particular instruction says. Barrel shifter will do that. Even you can try with different things. Instead of left shift, I can go for right shift also. LSR. LSR. So LSR, what I will do? I will go 55. Then I will go for LSR by one time. Let us see what's going to happen. Okay. Project stop. Project build target. Then debug start. So R1 is 55. That is 0101 0101 something it's going to be. Then right shifted, logical shift right. Then it is going to be, it is only shifted, the last bit will move away, then it's going to become 001010 like that. It will be, when you shift it, here it will be it is 01010101. Here it's going to be 00101010, and this one has been vanished. This has been vanished because it has gone away from this. So now I'm adding this one. This is 1111. See here 1111. That is going to be F. Then 1110. That's going to be 7. See, this particular one has been vanished. It has gone out. When I add these two, I will be getting 0, 1, 1, 1, then 1, 1, 1, 1. That is equal to 7. Yeah, here it is 55. Here it is, what is the value? 2A. When I add these two, I'm going to get 7F. That is what I'm getting. 7F is the answer over there. Are you getting? I have done logical shift right. Since I have given logical shift right, I have given the bigger number. See, bigger number you're supposed to give. What is the actually? It's a 32-bit number. I can give like this. 8 times. 8 times I can give. 1, 2, 3, 4. Okay, 8 times. When I do this, this is the 32-bit number. Now let us see what's going to happen. I'll stop it. Save, project, build target. One error is giving. Line number 5, immediate. Line number 5, immediate. 0x cannot be represented. Okay, so we are not in a position to give the value more than 255. They are telling. Okay, it will be solved. Project build target. Once again 0x. Some issue is giving. Okay, no errors. Whatever I have given previously, the same thing is coming. It's not taking the bigger number. We'll see it later. Okay. Hope, because I have to continue with my this one instruction. Let me stop the execution there. This is a simple example of how exactly LSL and LSR is going to work. See here, one more thing I'd like to say. Moves, moves and add as also you can check it out. Add as also you can check it. Let us complete this. Save, project, build target, debug, start and stop. See here, NZCV, NZCV IFT is been given. This is the inside the CPSR. The CPSR is shown. Now I'll go for first step. 55 has come. Carefully watch it. Nothing has been changed. No issue because no data has been changed here. But the same thing when you go for left shift and when you make it 0, assume I am going to make it 0. When I make it 0, then it's going to be a problem. I'll do AND operation. If I do, I'll do AND operation. Okay. Now we'll check it. Stop. Project. Build target. 0 error, 0 warning. Debug. Start and stop. First one. Now I'll select CPSR. See, first number is 55. Next number is 2A. That is 55 is, it is like this one. And next one is like this. But when I perform AND operation, it is going to become 0, 0. It's going to become 0, 0. So AND S, if you give, it will update 0 flag will check, make it to 1. We'll go for AND S. Is it possible? We'll check it out. AND S. I'll try with that also. Project, build target, no errors, debug, stop. First instruction, go for CPSR, check it, that is 0. Now you see what I did, and S I did and S. When I do and S is showing here. So and S showing here. Here I am going to have yes in the sense update all the registers. Here you see the registers have been updated. Previously they are 0, 0. Since I have given and S, if I give only and, it will not update the register, this one flags. If I give and S, it is updating the flags. Previously Z was 0, carry was 0. Now Z and carry has been changed over there. This one has been explained in the previous instruction also here. Here it is. Yeah, here sub S. In this sub S, they have shown how it has been changed. Z and C has been changed over there. Same thing we could able to do that. So let's move ahead. So this is R operation. Here also we are going to give R operation R0, R1, R2, R0, R1, R2. It's going to be R1 is 02, 04, 06, 08. R2 is 10, 30, 50, 70. When you R them, logically they are going to R and finally you are going to get 1, 2, 3, 4, 5, 6, 7, 8. You are going to get the answer. Similarly, example to show more complicated logical instruction like BIC, bit clear. Bit is going to be cleared over there. See, R1 is 1111, R2 is 0101, bit clear R0, R1, R2. When you do that one, whenever same bits are there, it's going to clear it. 1 and 1, it's going to be clear. 1 and 0, it's retained. 1 and 1, it's clear. 1 and 0, it's been retained. Now we can try this in our example. I'll try that in our example. R0 is 1111. R0 is 1111. Hope people are getting it. I'm simultaneously I'm writing the program also so that you can understand how exactly it's happening. Now, once again, move. I'll make this one as 1. I'll make this one as R2. Then I need to change it to 0x 1 0. Okay, 0 1 0 1. Now move. Sorry, not move. It is BIC. BIC R3, comma R1, comma R2. Now let us see what's going to happen. Save project, build target, 2 errors, showing 2 errors. What they have given in the textbook? Oh, binary. Sorry, I have given the hexadecimal here. I should give binary. That's the problem. It was showing. Still missing comma. Where it is missing comma? Line number 5 and 6. Oh. They were assigned. Directly they were assigned. Is that correct? BIC or not? Okay. Save project build target. There is some issue is coming. Unknown opcode R1 0B 0B only given. Just 1 second. R1 is 0B1111, R2 is 0B0101, VIC R0 R1 R1. Same thing I have given. Try with move R1 comma move R2 comma #2 should work. 0 number. Since it's a number, I need to give the hash only. 3 missing comma. 2 errors. Where it is missing comma? 0B binary. Still there is an error. Okay. I'll check it. I'll check once. If not working, then we'll move on. Yeah. Any issue? If this is not working, I'll move ahead. I'll see. I'll correct it and I'll come to you. Somebody is speaking background. Anirudh. Okay. Let us go ahead. See, now we'll move on to the comparison instruction. Last class I stopped here. Compare instruction. It can compare. It will compare the two registers and will give the values. It will give plus or minus. Both are equal. Both are not equal. Compare negative. It negates the value and will compare that one. It's been done. See here, that's been same thing has been given here. R0 is 4. R9 is 4. Compare R0 and R9. Both are same. Then Z flag is going to become 1 because 0. Output is 0. It's comparing. Z is going to become 1. So this is comparative instruction. Then multiply instruction. I have told you it can multiply. MLA, multiply and accumulate. MLA means multiply and accumulate. The multiply instruction multiply the contents of a pair of registers and depending upon the instruction accumulate the result with another register. Two source registers RS and RN that will get multiplied and it's going to be accumulated with the RM value. See here, the long multiples accumulate on a pair of registers representing a 64-bit. That is long multiple, we'll see later. Okay, MLA, multiply and accumulate. What it is doing, RM and RS is multiplied. See the instruction here. Rm and Rs is going to be multiplied, two source resistors, and the third source resistor, that is Rn, that will be accumulated. Finally, that result will be stored in Rd. But in the mul instruction, Rm and Rs is going to be multiplied, it's going to be stored. It will be stored in the destination register called Rd. This is simple. This instruction is very simple. But MLA, what we are having, MLA, it multiplies Rm and Rs, then it will accumulate with Rn, then that will be stored in Rd. This is somewhat peculiar instruction which is available in ARM processor, which was not there in your microprocessor. There is no accumulate instruction was there. Here it's been added over. Similarly, we'll go for long multiple. Okay, there is signed multiple accumulate long. L means long. The long MLA, you know. S means signed. L means long. Here signed multiply long. Here it's going to be accumulation. First one is accumulation, but the second one is there's no accumulation, only simple multiplication for the longer value. Long in the sense which is big in size. The size of your register 32 plus, then it's going to be here RD high, RD low, high and low. That is destination register high, destination register low, plus RM into RS. See here, RD low, RD high is there. RM and RS will be multiplied, and whatever the multiplication result comes, that will be accumulated with RD low and RD high. Here it's going to what's going to happen? Simple multiply, and they will be stored in the higher word and lower word. Higher word and lower word is going to accumulate. Similarly, unsigned multiply. S means sign, U means unsigned. It will not consider the sign value, unsigned multiplication it will do. Both are same, unsigned multiply. This is the result will be same, but only whether there is a sign or no sign, it's going to check that. The number of cycles taken to execute multiply instruction depend on the processor implementation. The number of cycles taken to execute a multiply instruction depends on the processor implementation. For some implementation, the cycle timings also depends on the value of source register. For more details on cycle timings, see appendix D. Okay, then we'll see later. So this is very, very important. Whenever you go for multiply instruction, multiply will not take a single cycle. It will take depending on the size of the data. The size of the data, what we are having, 8-bit data, 4-bit data, 16-bit data, 32-bit data. Based on that, it's going to perform the operation. So this is where the instruction has been given. R0 is 0, R1 is 1, and R2 is 2. Sorry, R2 is 2, R1 is 2. 2 and 2 will be multiplied, and that will be stored in R0. R0 is going to become 4. Simple 2 and 2. Long multiple instruction. See here, SML, UML instruction. R1 and R2 will be see here, R2 and R3 is multiplied, or the instruction multiplies register R2 and R3 and places the result into registers R0 and R1. These two will be multiplied. Since it is a long, it will store in R1 and also R0. 2 and 2, it will multiply. Then 4 is the result, and R1 will become 1. I is going to become 1 over there, because here it is F is there. F is there. See, F, it is not simple 0, 0, 0, it is F 0, 0, 0. Since it is F 0, 0, 0, you are going to multiply, and finally you are going to get 1. That is like a carry. So let me stop it there. Branch instruction will see. That's what I told you. B we have used in our program. A B instruction we have used here. That B instruction will come in branch instruction. In this, we are going to check it out. I am going to stop it now. Any issues? Anything you want to ask? Today we have discussed branch instruction, means some part of the branch instruction. Multiply instruction we have discussed. Okay, how exactly multiply? What is addition, subtraction, multiplication instruction, compare instruction? We have discussed. Let me stop it now because next hour you are having one more class. I'm stopping. Any issues, anything you want to ask, you can ask. I want everyone to go through it, and I told you install. See how I am executing in the class. You can execute and check it out. Yes, Baibu, you are trying to ask something. LPC 2148 is the processor you should have.
Okay, sir.
Fine. I'm stopping it now.
Thank you, sir.